Assalamualaikum warahmatullahi wabarakatuh. Today we will present for subject Power System Protection VEI 4833 for assignment 1. We are from group 5. My name is Ahmad Ashraf bin Ahmad. My metric number is B0819103030.
Hello, my name is Muhammad Asad bin Alwi. My metric number is B0819100023.
Assalamualaikum. My name is Azrai Nazrin bin Azali. My metric number B0819102001.
Okay, my name is Muhammad Zulfazli bin Marazi. My metric number is B0819103116.
This is our title, or we can say our incident, an analysis of the August 9, 2019 Great Britain Transmission System Frequency Incident. Okay, the incident time happened at 4:52 p.m. on 9 August 2019 on Friday. The incident, the Great Britain Transmission System experienced a single circuit fault caused by a lightning strike. This led to system frequency eventually falling from an initial 50 Hz to 48.8 Hz and triggering. The event also triggered disruption to rail networks during rush hour period and impact critical facility including an airport and a hospital. We can see the frequency is dropped from 50 to 48.8 in this graph. Okay, next. Protection system involved in this incident. DG protection setting had been updated in accordance with new rules approved by Afghan. The impact better response provision for frequency containment could have had on the outcome of the incident, showing clearly that widespread disconnection could have been avoided if a higher percentage of broadcast service had delivered. The role of DG and of protection system in the event, showing that improper operation contribute significantly to the severity of the incident. This include emergency alert, transmission activates, protection system performance, and reserve margin, and go far beyond the radio limited information published by the TV transmission license, which often has seen content from so long.
So the main root that cause of this incident, the Great Britain transmission system experienced a single circuit fault caused by a lightning strike that result in the unexpected and near simultaneous loss of two large generation source as well as a large amount of distributed generation. This led to a system frequency eventually falling from an initial 50 Hz to 48.8 Hz and triggering for the first time in 11 years. The system operators under frequency load shedding scheme known as low frequency demand disconnection LFDD, which interrupted electricity supply to around 1.1 million customers. The event also triggered disruption to rail network during rush hour period and impact critical facilities. The impact of the incident. So, in isolation, each of these failing may not have caused any noticeable system disruption, but in aggregation, they lead to the disconnection of 1.1 million customers. Two large generating stations failed to ride through a standard transient transmission line fault outage. The avoidance of either or both of these failures would have meant no system interaction occur. Distributed generation has been identified as a major factor in the incident, contributing as much disconnected generation as the transmission system. And the total loss of in-feed across the course of the event was well beyond that of a single loss of in-feed to which the ESO is obliged to secure the system.
Okay, there is some issues that related to the incident. Firstly is about rail. The impact on the rail network was severe. There were 23 trains evacuation and thousands of passengers had their journeys delayed with 371 trains cancelled, 220 part cancelled and at least 873 trains delayed. London's Sub Pancras and King's Cross station had to close for several hours due to overcrowding, and London Euston when exit only for a period of time. It all happened on Friday around 5 p.m. In example at the worst possible time, and it was this rail chaos that was the main source of public anger and made new headlines. Next is about health. Two hospitals were affected by LFDD with their backup generation working as designed. Another hospital was affected by the fall in frequency voltage execution, despite not being disconnected as part of LFDD. This was due to incorrect protection settings on the hospital's on network, which resulted in the site switching over to backup generation and one of its 11 generators failing to operate. Okay, next is about water. Uh, Approximately 3,000 people experienced water supply disruption due to booster water pumping station failing to automatically switch over to backup power supplies. Some of these customers would have experienced a temporary loss of running water in their homes, but others would have remained unaffected due to water storage in the system, allowing running water to continue. The majority of customers will restore within 30 minutes. Next, lastly is about other energy. An oil refinery was disconnected as a result of the site system, which detected a drop in frequency and disconnected the plant to protect on-site equipment. The refinery operation team utilized the site's emergency procedure and automated system to safely shut down portion of the plant. However, due to the complexity of restarting large process units, it took a few weeks to restore normal operation.
Okay, how to prevent these incidents. First, increasing a number of generator of or interconnector that make use of electronic converter. This allow much greater control flexibility relative to traditional directly connected electric machines. Second, using publicly available data and a dynamic simulation to reproduce observation record using PMU. A precise timeline of the incident has been generated that produce a very strong match to the observed system frequency response. Third, moving LFDD relay to a lower voltage level. Next is LFDD scheme should be investigated as a priority to reduce the risk that high penetration of distributed generation are to negate the effectiveness of the scheme during future events. The lastly is delivering a resilient system cost effectively require the right mix of operations, decisions, control facilities, logistic and asset with the right specifications.
Okay, that's all from us. Thank you.
Thank you.
You